Dear students, in this video we will discuss the very important topic in remote sensing, which is called resolution. If you want to define resolution, you can say the quality of the data collected by a sensor, it depends on its resolution. So it is a very important part of sensor. So there are four kind of resolution. The first is the spatial, then the spectral, then the radiometric and the temporal. So these are the four type of resolution we study in remote sensing. The first is the spatial resolution. So we can define spatial resolution. It is the ability of a sensor to detect a smallest object on the target. Means how much small object a sensor can identify, that defines its spatial resolution. Like if we take example of a camera or a mobile, like you are having a front camera of 8 megapixel and a back camera of 50 megapixel. It means the back camera has more spatial resolution. So when you are increasing the megapixel quantity, you are increasing the spatial resolution. Or we can take an example of eagle. So when an eagle flies on a height, it detects the rat on the ground. Rat is a very small animal, but she identify from that elevation. It means the eagle's eyes have the more spatial resolution. That's why she is capable to identify the rat on the ground from that flying height. So this is called as spatial resolution. Or if we, in remote sensing, we can take example of Landsat 7. It's having 15 meter resolution. It means object of 15 by 15 can be identified by the Landsat 7. But if you take example of IRS, it has the 6 meter resolution. It means it can identify a 6 by 6 meter object very clearly. So we can say IRS have more spatial resolution than the Landsat 7. So this is an example of spatial resolution in remote sensing. Now we move to second resolution, that is the spectral resolution. As the name is identifying, it depends on the spectral band. Means the ability of a sensor to work in different spectral bands. It will define its spectral resolution. So a sensor which can work in multiple spectral bands, it will have the more spectral resolution. Like in multispectral, the sensor use 3 to 10 bands. So and in hyperspectral remote sensing, the sensor use more than 10 bands. So we can say that the hyperspectral remote sensing has more spectral resolution than the multispectral. So in this way we can differentiate between the spectral resolution. So the multiple bands when we can use from a sensor, so it means it has the more spectral resolution. Here we can take an example of some animals can see they have the night vision also. So it means if they can see in the day, they are having the visible spectrum. Their eyes are working in the visible spectrum, and even if they can see in the night also. So it means they are also using the infrared band to see in the night. So it means their eyes have both their eyes can work in both spectrums, visible as well as infrared. So it means they are having the more spectral resolution. Like our human eyes only can see in the visible light, so we are having low spectral resolution. So next is the radiometric resolution. It is the ability of the sensor to differentiate between two energy. When there is a similar kind of objects are being identified from a satellite or from a sensor, so the sensor should have the capability to differentiate between them. If there are two trees, one is more green or having the dark green color, if the other having the light green color, so that time we need the radiometric resolution. Like if there is a black color, if there is a Z black, so differentiate between these two shades. This ability of the sensor is known as the radiometric resolution. So differentiate between the energy or the signature which is coming from the object, which is having the same frequency or wavelength. Very minor difference is there in frequency and wavelength. That minor difference should be catched by the sensor, by which ability, that is the radiometric resolution. Like when girls went in market for shopping, that and when they purchase clothes, so they can differentiate between the shades. They have the shades of pink, they have the shades of the red, but boys have have not that much idea of shades. For them pink is pink, but for girls pink has so many shades. So we can say that the girls having the more radiometric resolution than the boys. For example, I am just saying, so this kind of ability of sensor is called as the radiometric resolution. In the other hand, the temporal resolution, the fourth and the last, this is simply the revisit time of the satellite or the sensor. Like the polar satellites are moving from pole to pole. So when they capture a particular image of a particular target, they again revisit that target or that area after a particular time. So if a satellite is coming back on that area after 12 hours, or another satellite is coming after 6 hours, so it means the satellite or the sensor which is getting the next image in 6 hours, it has the more temporal resolution than the sensor which is providing image of that area after 12 hours. So it is simply the time between two successive image of sensor of this same area, that same area which is being captured by a sensor, in how much time the second image it will provide, that will define its temporal resolution. So the revisit time, if it is minimum, it means the temporal resolution is higher. The satellite or the sensor which have the minimum revisit time, they are having the more temporal resolution. So overall, the sensors which are having better resolutions, all the spatial, spectral, radiometric and temporal, they will provide more more refined data or more quality data to the receiving end. So that's why we work on the resolution. We increase the resolution of the satellite to get more quality data from the remote sensing. So these are the 4 type of resolutions in remote sensing. I hope you understand these concepts. If you have any doubt, you can ask in the comment box. Thank you.